Well, we've been talking about finding y-intercepts and x-intercepts, so let's look at a couple of examples. And let me direct your attention for what we're doing here to your book on page 15. This is in example 3, find y-intercepts, and I'm looking specifically down at the bottom of the example where it's talking about guided practice 3a. So let's say that we've got a function here, f of x equals x cubed plus x squared minus 6x plus 4. So taking this on the steps that we're going to do, of course, when we are looking to find the y-intercepts, we're going to set the value of x to 0. So this would be 0x cubed plus 0x squared minus 6 times 0 plus 4. And when we algebraically solve this, obviously 0 cubed is going to be just 0. 0 squared is 0. And minus 6 times 0 is going to be 0. And so we're just left with our y-intercept is 4. Now, in a function like this, and when we look at this, we could actually have gone right back here and just said, hey, that y-intercept is going to be 4. Well, let's look at another example of finding a y-intercept. This one's got a little bit more complexity to it. Again, this is direct to your book there on page 15 at the bottom of example 3. And here they use h of x. I like f of x. I don't know why they want to change the letters all the time, but they do. Okay, so where h of x is equal to the square root of x squared plus 6. So this one's obviously got a little bit more complexity to it. Sorry, 6. And we're going to have to solve this, but we're going to do it the same way. We're going to set the value of x to 0. So here we'd have 0 squared plus 6. Well, 0 squared is 0. It's going to leave us with the square root of 6. And so the y-intercept is the square root of 6. But if we were to mathematically compute that, we would find that the square root of 6 is equal to 2.45, and the decimals continue. So we could say that the y-intercept is approximately 2.45, or we might just say it's approximately 2.5. Let's look at an example of finding an x-intercept, and I'm looking at, if you go to page 16 in your book, and on example 4, this is guided practice 4a, and it's asking us to determine the zeros of 3x cubed minus 10x squared plus 8x. And so as I factor this equation, I'm going to set each of these factors equal to 0, and that's going to determine the zeros of this function. So in looking at this, I can see that each of these terms have an x in it. You got the 3x cubed, the 10x squared. Oh, excuse me. That should have been 8x. So let's put that back in there. We're going to be all messed up. So we got an x here. And so I can see immediately that I'm going to factor out an x. And that when I do, I'm going to be then left with 3x squared minus 10x plus 8. Now, don't want to forget here that I factored out this x. I'm going to go ahead and set it up here as x is equal to 0. And so one of my zeros, as I'm going to find out, is actually the whole number 0. Now, we need to then come in here and factor this quadratic equation right here. So let's take a look at that and factoring that. And so I can factor that by 3x minus 4x minus 2. Now, if I want to check my work in here, I can FOIL this. I mean, 3x plus x is 3x squared. 3x times minus 2 is going to give me minus 6x minus 4x here, and then minus 8 here. And so I've double checked, and I can see that these factors of 3x minus 4 and x minus 2, when I FOIL that back, is going to come to 3x squared minus 10x. So let's take each of these factors. and set them equal to 0. So I got 3x minus 4 equals to 0. And 3x is equal to 4, and therefore x is equal to 4/3. And then on the second factor, x minus 2, we set that to 0, and then x is equal to 2. And so my 3 zeros then are 0, 4/3, and 2. All right, let's look at another quick example here of finding x-intercepts. And a little bit different equation here. We've got h of x equals the square root of 4x plus 1. Okay, now I'm going to start here by setting this equal to 0. 4x, square root of 4x plus 1. What am I going to do here with this under the square root? Well, what I can actually do, and I'll just write this step down. You'll end up doing this in your head. But I can then square both sides of the equation. Remember, anything that I do to one side, as long as I do it to the other side, the same thing to the other side, it is actually legal in math. Well, of course, 0 squared is just 0. But the reason why I squared this is I want to get rid of this square root. I want this square root to get canceled, and I do that by squaring it. And so now I've got 0 equals 4x plus 1. Now, I'm just going to solve here for 0 because I want to find this x-intercept. And so let's see, now I've got minus 1 equals 4x. And I'm running out of room, so let's carry this back up here. Minus 1 equals 4x. And so the value of x itself is minus 1/4 equals to x. And my 0 in this equation is, my x-intercept, I should say, is equal to minus 1/4. Well, let's look at an example where we're going to find both the y and the x-intercepts. So let's say that we've got a function equation such as this. We've got f of x equals 2x cubed minus x squared minus 3x. Now, when it comes to finding the y-intercept, and to do that, I'm going to set each of these x values to 0. And of course, when I do that, everything is just going to go to 0. And so my y-intercept is just actually going to be 0. I'm just going to abbreviate that. Y-intercept is equal to 0. Now, I've got to deal with my x-intercepts. And on my x-intercepts, I'm going to set the entire equation to 0. But let's look here as I have to factor that out to do that. And I can see again that each of these terms has an x in it. So I can immediately go in here and factor out an x, which then gives me x and then 2x squared minus x minus 3. So one of my x-intercepts, I know automatically because of this x right here, is going to be 0. Well, I should put it right there. And then I'm going to continue and factor this quadratic equation to determine what my other two, or if I even have any other x-intercepts. So let's see here. I can factor this by 2x minus 3. I know that my last term here is a negative, so that I'm going to have a positive and negative within my parentheses. And my middle term's a negative, so I know that one of them is going to have to be larger. The negative is going to be larger than the positive. But I can factor this by 2x minus 3, and over here I've got x plus 1. So if I were to FOIL that back, well, the 2x times x gives me 2x squared. I'm good there. 2x times minus plus 1 gives me positive 2x. But here I've got the minus 3x. It's going to give me the minus x. And then, of course, minus 3 times 1 gives me the minus 3. I'm cool. I've foiled that back. And so let's set each of these factors then over to 0. Let's come right here. So I've got 2x minus 3 equals 0. 2x is equal to 3. And x is equal to 3/2. So that's going to be another one of my x-intercepts. And let's get on the other side here. X plus 1 equals 0. And x is just simply going to be minus 1. So I've got 3 x-intercepts in this. I've got a minus 1, a 0, and 3/2. And I'm done.